lot of what NASA's been doing and is doing has to do with systems engineering and pulling together lots of expertise to build complete systems that can solve mission goals and mission objectives and all that kind of stuff. So, I mean, that is basically what's happening here. I mean, they get a feel for what a real mission scenario and pulling together all of these disciplines and all of these expertise to complete some kind of mission objective.
It's a team effort, and there's a lot of things that are being done with really good teamwork, and there's some amazing people working in this group.
Well, of course, it's always fun to be able to work in a multidisciplinary team and see how all of the individual personalities come together and all of the different expertise areas and how that team dynamic forms. And of course, it's always different with every team that you get.
We're given a very fixed mission on a very fixed budget, and more important, on a very tight time schedule. Then it forces us as a team and students a lot of times for the very first time in their academic domain to deal with real world constraints. And we don't see that in our normal coursework.
I have learned a lot about the software and hardware interface. That's the critical point. Controlling that hardware with that software, this robotic aspect, made it so much interesting, so that you can move the arm. You're sitting here and move the tank on somewhere else. That is the major program aspect of this NASA project.
Finding solutions to design challenges that you encounter, and designing something that has to fit certain components and making sure it all fits together in the end.
NASA. Space exploration has ever been a man's dream, and NASA is making that dream a reality, and that's why we have to invest on this space exploration.
Today, I believe it's important because we really do exist in the generation that's going to actually explore space. In the past, we've done it from a armchair quarterback position, but I believe this really allows us to get our hands on and get equipment out there that's going to provide us with the trails for the future.
NASA does a lot of forefront research that isn't included or considered in what we think of as the space exploration program. And a lot of the technologies that get developed through that research are actually applied here today and now.
When I was in 7th grade, I wanted to be an astronaut. That was looking at those Apollo pictures and the gold helmet and all of that, and they're going on the moon and stuff. That launched me from the very beginning. That's always been an interest to me, and it's always been a motivator for me.
It's very inspiring to know that people can basically take a robot, blast it, I don't know, millions of miles away, and then actually have that function in a very harsh environment for orders of magnitude might be a stretch, but multiples of its actual forecasted life. So that's a very inspiring story.
It's important that we inspire students to get into STEM fields, into engineering, math, and science, and get them interested. And something like this really allows these students to see and get involved in a project that NASA is currently working on. And
that future generations of potential engineers that are out there, and just innovators in general, their inspiration comes so much from NASA and what they do, and this idea of being able to go out beyond Earth and explore the unknown is so inspirational for so many young people.
You create this excitement, and you create this innovation, you create this, you spark people's imagination, and for the United States, this is what we got at this point. Everybody can make something cheaper than we can, so all we got is being innovative and coming up with a new thing and a new idea. That's what we got, and NASA's a big part of that.